acknowledge Jess Bonnable for his commitment to reusable launch, affordability, aircraft-like operations. You know, going back to DCX and looking at history, there have been a lot of attempts to get ROVs going. We've had the X-34, the X-33, many other attempts. And you look back in history, we did it back in the 60s with the X-15 in a way. But since then, we really haven't accomplished as much as one would like. And Jess has been one of the people that have kept pushing through with his time at AFRL. And I just really want to acknowledge him for that contribution and dedication, because here we are today, and the question was asked earlier, why XS-1? Why now? And I promise I wasn't the one that asked that question, but in a moment you'll see that's kind of the title of what I'll be talking about. Before I do that, though, I want to say that as part of the theme of the conference, when you talk about 10 years and the power of 10, we've kind of been about 10 years away from the expansion, the rapid expansion of commercial space for 40 years. So every 10 years we kind of say, yeah, we're 10 years away. I remember in the early 70s as I was growing up, you know, all these magnificent things were going to be happening when shuttle came online and was able to provide routine and affordable access to space. We started to evolve into the 80s and 90s, and these X-planes came along and everything was going to open up. I was joking with Leonard off to the side a minute ago, and he said, yeah, it's been kind of like fusion. You know, we're always a few years away from it. So what I'll be talking about is why we're within 10 years. You've heard a lot of different perspectives on that today. What I intend to do is to weave that together into 4 main points that build around why XS-1 and why now, and how that is all enabled by everything we've been talking about here at the conference coming together to create that opportunity space for a program like XS-1. So first off, just to kind of get things started, on this chart is a picture of our concept. It's our booster. That's a portion of our architecture that we're working on. You won't hear a lot of technical details today. We really just got started on this contract a couple of months ago. But we are out there sharing a little bit about what our booster looks like and what that part of the architecture involves. And it really is all about reusability and affordable access, about aircraft-like operations. On the side of that vehicle, and you probably saw the model last night down in the reception area that we had, you saw that model and may have noticed on there there's a few logos on there. One of them is Scaled Composites. Scaled Composites is a Northrop Grumman company. Scaled Composites does a lot of prototype work. Most of you know that they're the ones that built the White Knight and spaceship that accomplished the Ansari Prize. They also received a Collier Trophy in 2004 for building that system. And so they've been with us about 10 years at Northrop. And it's funny, I get asked the question a lot, you know, what is Northrop Grumman's works? How come you don't have a works? You know, whether it's one works or another works. Well, all I can tell you is that we do work at Scaled Composite. And they're a very important part of our team. They do exceptional prototype work, and they're a significant partner to many of the NewSpace folks that are out there, including Virgin and Stratolaunch. Virgin's also part of our team. We've worked a lot with them over the years, particularly through the Scale relationship. We have very close ties to many of the people in the leadership team there that have developed over the years, and we're very happy to be partnered with Virgin on this program because they bring a dimension to this that as Northrop Grumman, we don't necessarily live in all the time. We're primarily a national security company, but for us, working closely with Virgin has brought a new perspective into the studies that we've been doing and some of the work that we plan to do in the future. So, solid team, and we're really excited about it, and looking forward to taking on future challenges. So now I'm going to get back to why XS-1, why now? 4 reasons. National security space, commercial, technology, and finally, certification and the regulatory regimes. Those 4 components, many of which have been talked about here in the last couple of days, really have bearing on this program going forward and why, after many attempts in the past, this program will be successful and will make the impact on affordability and responsiveness that's being looked for. So I'm going to talk about each of those. First off, talking about national security and then about commercial. In the national security context, if you look at General Shelton from Space Command's talk that he gave just before retiring, he very clearly conveyed to everyone the criticality and the contested nature of what's going on in space today. The world in space has changed a lot in the last 10 years and is changing very rapidly at a pace that no one ever predicted would happen. This is causing DoD to go through a rethinking of all their major mission architectures, looking across missile warning, protected communications, GPS. All those architectures have basically been in production of late and are evolving to what the future needs to be for those. And so the DoD is very focused on resilience, the ability to adjust and modify those architectures as events occur in space. That flexibility is very important. That flexibility also drives a need for responsiveness. Underlying all that, and Jess mentioned it in his presentation, is the affordability aspect. Changing all those architectures and going to new ways of building systems and getting away from our sort of strategic space infrastructure and getting more tactical, more versatile, more agile can only be done if it's more affordable. If you look at the cost of major space systems today, generally about 40% of it is launch. So certainly as a major system provider, we have a big interest in seeing the cost of launch go down, because then it means more things can be done to deliver capability rather than just get the capability up into space. So affordability is key. You know, you look at history, look at the Navy and contested nature of history around the world. Look today at the Spratly Islands and what's going on with ships there. That kind of future is what lies ahead for space. Doug talked about it yesterday, the collision of commercial and national security. It's really with us now. It's going to heighten as more and more things get up there, as people start talking about super constellations of small satellites, as our adversaries continue to build out more and more capability and fly it in space, as our other mission partners do. So really a national security imperative is there. On the commercial side, there's two dimensions to that. Some have been talked about. I won't repeat a lot of what was said, but the two components I'm referring to is the proliferation of commercial capabilities. This isn't the teledesic era where in the late 90s, teledesic had a big initiative along with Iridium. A lot of satellites were going to go up. It skewed a lot of people's market predictions. A lot of people got into that. A lot of RLV programs started then, but kind of teledesic went away. Iridium struggled through. The demand function wasn't there. Is the demand function here today? Well, you look at Moore's law and the evolution of electronics and how we've gone from supercomputers to what we hold in our hand today. That same impact, that same rate of change is occurring in satellite components, and one just has to look at the number of nanosatellites and microsatellites getting launched. Look at what Facebook and Amazon and Google are rumored to be doing relative to the need to get up small satellite constellations, because bandwidth is going to be crazy. If it's not crazy now, it's going to be much worse in the future. I think it was Clay yesterday that mentioned the Fitbit for the cow. I mean, the need for getting that data up, getting it out, is just going to overwhelm terrestrial infrastructures eventually. And in a lot of developing countries like Africa and Indonesia and others, that infrastructure doesn't exist. So there's real change going on the commercial side of the demand function, clearly. That's been talked about here. The other part of it is, I think George laid it out beautifully. He walked us through all the commercial things that are going on. I knew of about half of them. It was eye-watering just to consider all the rack and stack of those 11 missions. Very impressive array of things that are going on. Not all will be successful. The expected success of all that is not 100%, but if half of those things are successful, we're looking at a major inflection on the commercial side. In addition, the government is getting much more sophisticated in jointly funding space type of operations, and Gerst and his crew should be applauded for the work that they're doing in getting COTS online and now getting the crewed element online. 5 years ago, people thought that that was just an idea that was unacceptable and off the reservation, and look what it's doing today. So the government's learning how to do that, and in the DARPA case, the government and industry working together on a program in the long term is very rational after seeing the great success that went on there. So that's the commercial piece. If you look at the one aspect of commercial and DoD that kind of goes together is you start looking at these small satellites and you look at resilience and trying to quickly replenish satellite constellations, multiple satellites to replace a plane that might be knocked out, or trying to deploy a super constellation of 100 satellites. You know, you're not going to have enough mission life in those satellites if you don't replace them or have a way of rapidly deploying them. Otherwise, before you get the whole constellation deployed, you'll have to replace the first that went up because of the time it takes to get those launches done. So a lot of challenges here on the national security and commercial part, but the maturity's there causing this program to be real. And then lastly, on technology and regulatory, there is really no new technology. Just showed a chart about technology. We happen to believe that autonomy is central to how future reusable systems are going to work. If you look at the complexity of an RTLS type of flight and doing that in ever more congested and constrained conditions, and trying to do that and be able to do those kinds of flights on a regular basis and fly that kind of system, strong autonomy is going to be needed, and that's become very mature in the last 10 years. Autonomous vehicles today are not your daddy's RPVs or drones. These are very sophisticated aircraft that can control their own decision making. They can land on a moving aircraft carrier in all conditions. We're very proud of the fact that we recently won the Collier Trophy for the X-47B for doing just that. And those are the kinds of capabilities that are going to need to be brought to reusable launch vehicles coming forward in the future. And those mature technologies are very mature. So 10 years ago, that would have been impossible. Today, it is very possible. Structures, lightweight structures are much more common and proliferated. And then finally, talking about the regulatory aspect of things. Regulations 10 years ago, again, we really were just sort of fumbling around thinking about that, trying to conceive of how that's done. Today, there's 9 spaceports out there. You know, people are doing what's needed. People are collaborating. George and his team in the last 10 years have really built up the knowledge base and the infrastructure needed for understanding those regulations. The work to be done there, the challenge left, though I think Doug Lavero put his finger right on it, which is the collision of space and national security. How we do that in the in-space world is still yet to be seen, and I would encourage those that are considering looking at that to look at naval history and the challenges that have been dealt with there and some of the ways they've been resolved, because it's going to be very similar. Countries vying for different areas and different dimensions of the space world. So just to kind of summarize and finish up, I believe it's national security, the commercial market demand and commercial capabilities, technology maturity, and regulatory maturity. All those things are coming together that say now is a really good time for the government to really try to drive down the lower payload class to get to responsive and affordable launch. And that's, you know, those things intersect, and it intersects between commercial and national security very well. And then finally, as a word to the conference, I just wanted to make the comment that a lot of us in our businesses and other places talk about diversity and inclusion. And I think one of the hallmarks of this conference is the diversity of thought that is brought forward in these presentations and in the rooms on the side. Nowhere do you see this kind of diverse perspective, experience base coming together, looking at a tough problem. So I acknowledge the conference for that. So that's all I have for today, and look forward to talking to anyone outside. Thanks.